Electrify your life. First, I'd like to acknowledge the cultures, flora, and fauna that we rely on for our existence, and that we will honor the responsibilities to ensure livable ecologies for future generations and cultures. I'm Court Smith, one of the founders of Electrify Corvallis, and an advocate for more robust climate action. Electrify Corvallis is a local nonprofit. The Electrify Corvallis mission is to build an electric future together by reducing the greenhouse gas emissions that are warming our planet. Electrification is the best way to transition to clean, renewable, reliable electric power instead of burning fossil fuels like natural gas in our buildings and in our transportation. Electrify Corvallis has been focusing on three themes. First off is retrofit options for buildings, and that's what tonight's webinar is mainly about. We're also trying to educate people the urgency to mitigate and adapt to climate change. We cannot wait longer. Emphasis on the short term, that the best thing we can do in the short term is to reduce methane. Natural gas is the best short-term option we have. You can learn more about Electrify Corvallis at electrifycorvallis.org. I believe the web address is in the chat. The Corvallis Sustainability Coalition is a co-sponsor for tonight's webinar. The coalition includes over 300 local organizations working to increase sustainability locally with actions that are chosen using a climate lens. Now let's get started. Please write your questions in the Q&A. We are going to have a substantial time for questions at the end, and we want to be able to get your questions. So put them in as you think about them so you don't forget. We're going to start off with our keynote speaker, Brian Stewart. He's a business executive and leader who has moved from the corporate area into the nonprofit sector as a co-founder for Electrify Now. Electrify Now has a wonderful website and is a leader in providing information that's comprehensive and informative on their website and in programs like these, which will provide you with some of the how-tos to electrify. So Brian, if you'd start, we'd appreciate it.
Thanks, Court. And welcome, everyone. And I'm really excited to be able to share this information with you. Basically, just a little background. My wife and I started Electrify Now 4 years ago because we were frustrated just that there wasn't good sources of information around some of these really important things we can do. I think a lot of the public dialogue at that time was really focused primarily on recycling, which is important, but it felt to us a good conversation about energy and the important role that energy plays in our future, as well as what we can do as individuals. So that's really what we're going to be talking about tonight. And we call this the benefits of electrification because there are so many of them. But we'd like to start the conversation at a pretty high level because I would include myself in this by saying that most people don't really have a good idea about where carbon emissions come from. I was a corporate sustainability officer, and I don't think I really had a clear picture of this until I left and started doing some of my own research. But when you look at the available data and you add the numbers together in ways that are different than what they typically present to you, what you see is that over 80% of the emissions in this country, and it's fairly typical around the world, come from burning fossil fuels for energy, and specifically energy for electricity, transportation, and heat. Three things that we as human beings really won't do without. So while there might be some opportunities for using less of those things, the main problem is to figure out how to do this without burning fossil fuels. So you can see the majority of the emissions come from energy. Agriculture, yes, there are agricultural emissions and industrial processes like making cement, for example, produces them, treating waste, water, etc. But the majority is energy. At the household level, it's a similar picture. This is from the Union of Concerned Scientists that shows that 60% of the emissions that we as individuals are responsible for come from the energy that we consume. Think of it as the energy that you purchase directly. So this is your electricity bill, your natural gas bill if you have one, the gasoline you purchase to put in your cars. That energy that you buy, that we all buy, is the vast majority of our personal carbon emissions. Of course, there's energy related in the stuff that we buy, clothing, furniture goods, that sort of thing, and the food we eat. But it's really hard to eliminate those emissions. We have to buy food. Yes, we can buy food from local sources, or organic or regeneratively raised agriculture offers tremendous prospects to lower emissions, but it's hard to eliminate these. This big blue box here, the 60% though, it's entirely possible to completely eliminate that in your home. We've done it on ours and helped many people around the state and around the country to do the same. And that's really what we'll be talking about today. And the reason for this is because electricity, for the most part, has come from coal and natural gas. We have a lot of hydro here in the West, and more renewables, but historically, and still, coal and natural gas are a huge portion of our electricity generation. And of course, gasoline and diesel that we put in our cars, and it's our cars, by the way, that are the big problem. Cars and trucks, much more of a problem than even air transportation, although that's an issue as well. And then of course, heating our buildings and heat for industry is another big source. And there's a lot of conversation about renewable natural gas and those sorts of things, but really we have to figure out how to eliminate burning fossil fuels. So the mindset that it's important for us to adopt is how we stop using fossil fuels. Using less of them is not sufficient. We have to eliminate them completely, really, in order to get where we need to go. But the good news is that the lowest cost source of energy now is the energy we can capture directly from the wind and the sun. And this is because solar energy cost per million megawatts or megawatt hour, and wind has just plummeted over the last 20 years. You can see the trajectory they're on with these two white lines. So now they're actually cheaper than gas and even existing coal plants, nuclear, etc. This is true in the United States. It's true in most of the world now, not every place, but most of the world sees a similar picture, and costs are projected to go further down for solar and wind. And the IRA, which we'll touch on a little bit later, has some provisions that will help to reduce those costs in the future. The same is true for battery storage, by the way. All these renewable energy technologies are following those same curves. The other thing that's been happening, which is maybe less dramatic, but it's been happening kind of gradually over time, is that electric appliances are becoming dramatically more energy efficient. The LED light bulb is kind of the poster child for this because it's literally 10 times more efficient than an incandescent bulb. But the same is true from your refrigerator, your TV, your stereo, your laptop. Everything that we use that uses electricity is sipping it now, whereas it was guzzling it even just a few 10 years ago or so. The same is not true, by the way, with gas burning appliances. They're largely the same efficiency that they were 30 or 40 years ago, primarily because the gas industry has been so effective at fighting standard increases to efficiency. So the appliances are getting more energy efficient. The grid is getting cleaner literally every day. And of course, every year. This is the plot over the last 20 years or so, and you can see how the emissions from the electricity sector here in the United States are actually going down, even as we're using more electricity. And so think of it this way: every time someone puts solar panels on their roof, the grid gets cleaner. But every time you drive around along Highway 84 and see one of those wind turbines being hauled behind a giant truck, that is the grid getting cleaner before our very eyes. So when you combine those things, cheaper renewables, cleaner electricity, really efficient electric appliances, you get to this conclusion that we should be electrifying everything. And it's this terminology you'll hear more and more, and it really conjures up this concept of a future where we're getting all of our energy from the wind and the sun for everything that is one of our primary energy needs: electricity, transportation, and heat. This future has some amazing side benefits that often get overlooked in this conversation about carbon reduction. But cleaner air, how about that? Think about it this way. Where does air pollution come from? It basically comes from burning fossil fuels for the most part. Here we have forest fires, which cause air pollution, which is a byproduct of fossil fuels consumption. But really, for the most part, the smog in our cities comes from fossil fuels. There's inordinate amounts of water that are used to create those fossil fuels. I've seen estimates anywhere from 10 to 40% of the fresh water that's available in the United States is used for processing fossil fuels. And then, of course, there's lots of studies that show that this transition to clean energy makes better jobs and a stronger economy. So huge kind of co-benefits that come with this focus on decarbonizing our economy. But there is this stark reality which we cannot escape, which is that in order to prevent the worst effects of climate change, every single device on the planet that burns fossil fuels has to be replaced with a clean energy alternative before 2050. Really, if we go later than that, we are in dire risk of a planet that won't be inhabitable for ourselves, let alone our children. So that's daunting when you think of it, because it's literally thousands of coal plants and gas power plants and millions of cars and trucks and millions of gas furnaces and water heaters that have to be replaced with clean alternatives. But between now and 2050, nearly all of these things that are in operation today that burn fossil fuels will face the end of their useful lives. So it's important for us to have this mentality that whenever we have the opportunity to retire something, and if we can retire it early, that's even better, we need to replace it with something that's clean and not put new fossil fuels burning devices into the world if possible. Because we've got these really potent solutions. We talked about wind and solar for electricity. Electric vehicles are on the cusp of becoming the normal way to get around. I mean, I don't know if you've been watching, but it's pretty exciting. The sales of electric vehicles are close to doubling every year here in the United States. And we've got to about a little over 6% of new car sales so far this year are electric vehicles, up from about 3% last year. So it's conceivable that this time next year we'll be talking about 10% of car sales, and the year after 20% of car sales. So you can see how the future is there. The car manufacturers are all in. People are passing rules like in California to eliminate the sale of gas-powered vehicles. So the future there seems pretty clear. And then another area that is less well understood by the common person, I would say, is what happens in heating. And for heating buildings, heat pumps are the superior solution, which we will talk about. So these solutions are already here. Yes, there will be some technologies that we have to develop that aren't available yet, but mostly the problem that we have is about scaling the solutions that are already here. And that's where all of us come into play, how we can be part of this massive scaling exercise that has to happen. And the reason why this is exciting is because when you combine renewable energy and electrification together, it isn't just reducing emissions, it's eliminating emissions when those two things are combined. And one of the best ways to understand how this is possible is in our own homes. And think of it this way, that there's the four largest sources of energy emissions, carbon emissions in our home are the electricity from the electricity we consume, usually 3 to 5 tons of carbon emissions per year for a typical home here in Oregon. One automobile, 4 to 8 tons, depending on how big it is, how much you drive it, etc. One gas furnace, about the same, 4 to 8, and a water heater, a gas water heater, 1 to 3. These are likely the 4 largest sources of emissions that any of us as homeowners or renters or whatever will have in our lives. So if we employ efficiency measures, which is advisable, like turn off the lights, get a more fuel efficient car, turn down your thermostat maybe a little bit, take cold showers every once in a while. Nobody likes doing that. Actually, I kind of like doing that every once in a while. But if you do those things, which are hard to do consistently, you might reduce your emissions by 20% or so by being really diligent. But if you combine renewable energy and electrification, look what happens. Instead of 3 to 5 tons, it's 0 for your electricity. Instead of 4 to 8 for your car, it's 0 for an EV that's charged with renewable energy. Instead of 4 to 8 for a furnace, it's 0 for a heat pump that runs on clean energy. Instead of 1 to 3 for a water heater, it's 0. So a home that is typically 20 to 30 tons of carbon emissions every year, a typical home in Oregon will produce something like that. You can be producing 0 for your home and live in a home that's more comfortable. We'll talk about that. And also save money, because the cost of running a fossil fuels household with 2 cars and a water heater and a gas furnace is on the order of $4,000 a year. The electric version of that is more like $3,000. And with the increase in gas prices, this for gasoline, this disparity is becoming bigger. And also, you may be noticing that natural gas prices are also increasing really dramatically, which is going to make this comparison even more favorable. So this is what's beautiful about this. Renewable energy and electrification, you're going to live in a home that's safer and more comfortable. And the money that you do spend on energy, which will be less, is now being used to fund the solution to climate change instead of funding the problem. Currently, right now, most of our energy expenditures go towards buying fossil fuels. We're essentially sponsoring climate change with our energy purchases unless we take these actions to get renewable energy and electrify our homes. So we try to keep it really simple at Electrify. Now we talk about 4 steps. It's really important to get clean energy into your home, then get rid of anything you have in your home that burns fossil fuels. We had 10 different items in our home that burn fossil fuels. There's excellent alternatives for all of those things. Electrify your transportation, and then we won't talk a lot about it. I won't talk about it a lot today, but it's really important that we be mindful of the fact that we need to bring everyone along on this journey with us. And it's one thing for those of us who may have the means to do these things and access to capital to buy a new furnace or something, new water heater, but many people are struggling just to pay their electric bills. And so it's harder for them to make this transition happen in their homes. And so we need to help them. So we're going to start with cleaning up your electric supply, which is possibly the most important thing to do. It's also the easiest thing to do. But it's important because almost a quarter of the emissions in the United States come from creating electricity. Here in Oregon, it can vary really dramatically depending on your utility, because they will vary in terms of how much hydro, how much wind, and how much coal and natural gas they use. But as an example, Pacific Power, which I know you in Corvallis, many of you may have Pacific Power. It is the dirtiest supply of electricity in the state. It's well over the state average. And so a typical home would be more like 5 to 7 tons of carbon emissions per year from Pacific Power. Portland General Electric is a little bit cleaner, a little bit under the state average. And then Consumer Power, which is another option you have, is very clean, like an order of magnitude cleaner than Pacific Power. And Ashland Electric, just as another reference point in the southern part of the state, is really clean. I look at this map here as, so to speak, as kind of a view of where we are and where we're going, because with the laws that have been passed about clean energy for 2040, we're all going to be approaching Ashland soon, and by 2040 we will be well beyond even what Ashland has in terms of clean energy. But all of us can get clean energy today. We don't have to wait till 2040. And even if you're on Consumer Power, you might think of doing these things. There are green power plans from many of, like Pacific Power in particular, has a pretty good plan. It's called the Blue Sky Plan. You can sign up for it. It's a little bit more expensive per month, but it's a small price to pay for clean energy. Rooftop solar here in Oregon, a lot of people dismiss it because we have so many cloudy days, but it's still really effective if you have a home with the right exposure and if you're planning to live there for a while. But the other thing that is an amazing asset we have in this state, that if you're a Pacific Power consumer, check out the community solar option. There's links on our website on how to do this, but essentially you're subscribing to a solar farm right in the Willamette Valley that would be generating electricity on your behalf. And any of these solutions is a way to get clean energy to your home, and also to now be able to power everything you have with clean renewables. So we're going to spend most of the time on this section, which is about electrifying your home, which is in some ways the most complicated and the least known in some ways in terms of what's out there. But it's also important because there's a lot of misinformation out there. A lot of us grew up with this idea that methane is really clean. Natural gas is clean. That blue flame, it looks so beautiful. But methane is one of the largest sources of carbon emissions in this country. And as we get more data about how much this system actually leaks, that it becomes less of a good-looking alternative even to coal. And so many people will tell you that it's actually worse than coal in terms of its climate impacts. Regardless, it's also a huge source of indoor and outdoor air pollution, and one of the real challenges of our time to figure out how we eliminate this in our lives. But it's also very possible to do. The two big culprits we talked about in homes are your gas furnace and your gas water heater. And I like to, a lot of people have a trouble getting their brain around what a ton of carbon is, and it's almost impossible to really comprehend. But if this helps, imagine that you and I were walking down the street and we ran across a pile of plastics waste on the sidewalk. And there were 100 plastic bottles in there, and 100 shopping bags, and 100 forks, and 100 spoons, and 100 plastic knives, 100 of those plastic takeout containers, 100 yogurt cups, and 1,000 plastic straws mixed into this terrible pile of plastics garbage. We'd be horrified. And we'd be horrified to learn that there's 23 pounds of carbon was emitted to produce all that huge pile of trash. I think you'll be more horrified to know that one day of heating your home with natural gas is almost twice that amount of carbon pollution, and 1 gallon of gas is well over that amount of terrible plastics waste. So if it helps you to visualize when you're taking a hot bath and you're heating your water with natural gas, the emissions from heating that water is pretty close to the emissions that would be created from the plastics trash that would fill your tub. So if that helps you in terms of just kind of like a visual for how this invisible methane carbon pollution is, I hope it didn't ruin your hot bath. But it is possible to get zero emission space heating and zero emissions water heating. And the technology to do this is this mysterious thing called a heat pump. And a lot of people just kind of lock up when you try to explain it, and it's a little bit complicated, so I won't go super deep. But I think these things are also incredibly familiar. Our refrigerators are heat pumps. And essentially what's so magical about them is that they move heat from one place to another. They don't create heat. They don't create coolth. There's no such thing as creating coolth. But we can create a very cold environment inside this well-insulated refrigerator by moving the heat into your kitchen. So your kitchen gets slightly warmer. You hardly notice it. But if you put your hand behind the refrigerator, you'll notice that warm air, or maybe there's warm air coming from underneath your refrigerator. That's what it's moving the heat from inside to your room. So it's a very, very efficient process, and it can work even when your kitchen is hot. During the heat dome last summer, our kitchen was almost 100 degrees before we turned our heat pump on for air conditioning. We still had ice in the refrigerator. So even though it was 100 degrees in the kitchen, it was about 28 degrees inside the icebox of our refrigerator. So a huge, huge difference in temperatures can be created with this technology. It's the easiest probably to explain with a heat pump water heater. These things look just like regular water heaters, but what happens is they are bringing warm air from the room that they're in into this heat pump device on top of the storage tank, and then it harvests that warm air from the room that it's in, then compresses that, it heats up this refrigerant, then compresses the refrigerant to get it even hotter, and then that is used to run around in these coils around the water tank that heats up the water, and that cools the refrigerant, and it comes back and gets rewarmed. So what's happening is that the room that this is in is going to get slightly cooler, which is why it's best to have it in a basement or a garage or a large utility room. But the water can get really hot, like 130, 140 degrees. And And these things are 3 times more energy efficient than any other way of heating water, which makes them the lowest cost and the lowest carbon sources for hot water. And just to give you an idea of what this looks like, and it'll vary, I've got a slide like this for Pacific Power and for you consumer power folks. But electric storage is going to cost you about $520 a year. It's the most expensive. A gas storage water heater is $280 or so. This is why gas has become so popular is because it's cheaper. And then a gas tankless, which has this idea as being really the best thing out there, is slightly better than a gas storage. But a heat pump water heater blows all these away in terms of its cost to operate for 1 year. And from a carbon perspective, it's similar that the heat pump is by far the lowest carbon source of hot water. For consumer power, the costs are roughly the same, but the carbon picture is way different because the electricity is so much cleaner. You can see that a heat pump is barely creating any emissions at all. And of course, as we get on our path towards 100% renewable energy for everyone, or if you do one of those things we talked about, getting clean energy into your home, it's 0 emissions for a heat pump compared to 2 or 3 tons, depending on which gas solution you have. So that's why it's so exciting. Space heating, heat pumps can be used for space heating in the same way. And the thing that's really exciting about space heating heat pumps is they can operate both directions. A refrigerator, an air conditioner, a heat pump water heater is a heat pump that moves only in one way. For space heating, a heat pump can move one way to cool your house and move another way to heat your home with the same exact device and equipment. And you get a more comfortable home, partly because it's in a continuous operation. So it's moving air more consistently, which means it's going through the filter more often, which means it's cleaner. But it also means that because it's not doing this on-off thing that gas furnaces do, your home is typically more consistently heated, fewer cold spots, etc., because there's time for that heat to get everywhere. And same for cooling. There's 2 basic versions of these that you will hear about: ducted or central heat pumps, in which case you've got this external unit that looks a lot like an air conditioner, and then these refrigerant lines that connect inside to the air handler. So whereas the heat pump water heater was all in one unit, here we're talking about 2 separate pieces. But the refrigerant is pumping either hot or cold refrigerant into the air handler, and then the air handler blows air across the coils that have that either hot or cold refrigerant in it to blow either hot or cold air into your home. And it looks just like a furnace on the inside, but it's got this air conditioner-like device on the outside. A ductless system, it works the same way. There's an external unit, but now instead of blowing air through your ducts, the vents in your home, if you have a home that's got electric baseboard heating, for example, you don't have vents. So these are excellent solution in that case, because you can put these units, these heads, they're called, on the wall of your home, and it'll blow either hot or cold air into those rooms. You need one for every room, or there's versions of these that can also be put in the ceiling and do little small ducted runs. And there's combinations of these that are also available. It really depends on your home. So a good contractor will be able to tell you what's best for your situation. But these are the 2 kind of most common configurations that you'll see. And again, they can lead to dramatically lower energy bills. This is, again, 3 of the typical systems that are out there. If you look at older homes, they're going to have one of these systems. Oil furnaces are getting rare now, but they're on back east. There's a lot of them that we have. Some of them in Portland. I'm not sure about in your area, but they're the most expensive ways to heat your home. It can cost, several $1,000s a year to heat a home in Oregon with oil. This number up here, by the way, is the cost for 1 million BTUs. It's a relatively arbitrary thing, but a typical home needs 30 to 50 BTUs. So it's an easy way to compare the cost per million BTUs for these different technologies. So electric baseboard, you can see, also really expensive. And this is why gas furnaces became popular, is because they were so much cheaper to operate than either of these 2 older systems. You can get a new gas furnace, and which will lower your cost somewhat. You can get a gas furnace with a heat pump on it. That's kind of what's called a dual fuel system. And both of those things will reduce your emissions and your costs somewhat. If you go into the heat pump zone, this is for both consumer power and Pacific Power, because the cost of energy is very similar. This is typically what you would see for cost of heating with heat pumps. So it's comparable to the very best gas, in some cases cheaper, but definitely cheaper than the older systems that most people have in their homes that have been around for a while. From a carbon perspective, electric is the most, with Pacific Power, electric is the most carbon intensive, but you can see all these generate a lot of carbon emissions. A really good gas furnace is less, but heat pumps are quite a bit less, and even more so when you look at the consumer power picture. Because Pacific Power is the dirtiest, it's really important to get clean energy if you're a Pacific Power consumer. But you can see if you're a consumer power customer, you're already getting really close to almost no zero emissions heating. And of course, with renewable energy, all those go to zero. So this is the picture of the future, that we're all moving towards. And in the lifetime of one of these devices, like if you buy a furnace today, a heat pump today, over its useful life, it's very likely we'll be close to zero in terms of the emissions from it, just because the Oregon grid is clean, even without taking extraordinary actions. So these things are no compromise. You're going to be more comfortable, and you can avoid 5 to 11 tons of carbon emissions by taking these actions. They're not cheap, and the IRA, which I think we'll talk a bit more later, has some ways to save money, but they're really important steps and powerful steps that we can all take. The other thing that's important about these electric devices, and it's particularly important around gas stoves, your stove is not a huge source of carbon emissions, your cooking stove, but it will generate several hundred pounds of carbon over a year. But the main reason to get rid of it is to get off gas completely, but the second is because of indoor air quality. The information about the relationship between gas stoves and asthma causing emissions from carbon monoxide and nitrous dioxide is really stark. And even the American Medical Association, which is a pretty conservative body, came out stating that gas stoves are a risk to asthma and should be replaced in homes as soon as possible. So you can get peak indoor air pollution that happens in minutes. In the time that cooks to fry an egg, you're going to have air in your kitchen that would be illegal if it was outside. Even if you've got a vent on, it's not certain that you will be eliminating all those emissions from your home. And many of the gas vents the hoods that are over stoves that just blow the air back into the kitchen, that will not do anything to reduce the carbon monoxide and nitrous oxide emissions. So they're terrible for indoor air quality. And then we're also learning now that they leak even when we're not using them, which is another source of indoor air pollution, but also a source of methane emissions that's really bad for the environment. Induction stoves are so much better. Anyone who's used one will tell you it heats water or heats up twice as fast as gas. It's much easier to clean. It cools down quicker, which means that you can control the temperature much more accurately. And none of these harmful emissions come from combustion, and about 1/10 of the carbon emissions as well. So it's important to think about ditching the gas. We've talked mostly about space heating and water heating, a little bit about induction stoves, but your barbecue, you can get an electric barbecue. They're amazing. They're so much better than gas. No propane to fill, no charcoal briquettes. They do everything that a barbecue should do with none of those emissions. Gas fireplaces can be replaced with electric ones. No one would even know that it's changed, except that now you can control the temperature and you don't have the risk of fumes in your home. And gas power tools outdoor, one of my pet peeves, lawnmowers, leaf blowers. Electric ones are so much better. No gas to refill, no nasty, stinky, terrible pollution that comes from these things. They're more polluting than cars by far. And in California, the major source of air pollution is now these small engines, not automobiles. So you can see how polluting they are. When you electrify these things, you'll get better performance and comfort, better air quality, lower cost of operation, much easier to clean and maintain, and avoid lots of emissions. I want to spend a little bit of time on EVs. We're not going to go deep in this, but it's important because there's a few things that people don't typically understand about these, although I think EVs are pretty well known as a solution. But nearly 30%, and here in Oregon, it's more like 40% of our emissions come from transportation, and it's mostly cars. The vast majority of emissions are from cars and light trucks. And that's because one car will produce 4 to 8 tons of emissions per year. If you go to an EV, there's a lot of people will say, well, yeah, aren't you just trading one source of emissions for another? Because now you've got dirty electricity instead of dirty gasoline. This is a map from the Union of Concerned Scientists that shows the miles per gallon that you would have to have, depending on where you get your electricity from, because it varies across the country, the miles per gallon you would have to have in your car in order for it to be cleaner than an EV. And here in the Northwest, you would be having to get over 102 miles per gallon. If you have a Tesla, by the way, it's more like 130 because they're so energy efficient. But even in the dirtiest parts of the country where the grid is the dirtiest, you would still have to have a car that gets over 40 miles per gallon, which is way higher than the average, which is more like 20 or 25 here in the US. So yes, an EV is cleaner just with the electricity right out of the socket without even getting renewables. But the other thing that's really exciting about EVs, and one of the reasons why the car manufacturers see this as just like an inevitable, is because of how much better they are in terms of the cost per mile. I love this comparison. The Hyundai Kona comes in two versions, a gas version and an EV. The gas version, for $10, you'll be able to go 55 miles with the current cost of gasoline. With the electric version of that exact same car, you can go 338 miles. So 6 times farther with the same price of fuel. Now, of course, this will vary depending on the cost of electricity and gasoline, but it's always, every time I've done this calculation, it's been somewhere between 4 and 6 times more miles per dollar. So really exciting. And the other thing is that people, I think, don't get is that they're cheaper. EVs are cheaper than you think. And the reason why this is kind of confusing to people is because the sticker prices are so much higher. This is the Kona EV, which, by the way, has come down a few $1,000s since I've been doing this comparison, and the Kona gas car has gone up. But this is the current price, $10,000 different. The federal tax credit, and that's changing somewhat, but some version of this is still going to be available. The state tax credit, that takes $10,000 off the sticker price, so now you're at roughly parity. But if you look at the operating costs, the fuel costs, because of that slide I just showed you, you're spending over 5 years $1,500 instead of almost $10,000 on gas. And maintenance is virtually non-existent on EVs. It's windshield wipers and tires and windshield wiper fluid. So over the 5-year life of this car, you're going to save almost $10,000 by purchasing the EV. So if the sticker price can be a shock, but these things are cheaper to operate than you think. The other question that people always ask me is, yeah, well, what about the batteries? Well, here's another comparison from the Union of Concerned Scientists where I get a lot of my data, very trustworthy source. A mid-sized car is going to take about 9 tons of carbon emissions to produce it, but it's going to produce almost 100 tons over its life. This is why retiring things as soon as possible is important. Anything that burns fossil fuels, yes, there's some embedded carbon in it, but it's the operating emissions are so much worse. That's why it's best to get rid of things as soon as you can. Don't wait till they're old and dying. It's a financial decision to do it as soon as you can. An EV, because the battery is more energy efficient to produce, is more like 15 tons to produce a car of the same size. But with average electricity here in Oregon, it's going to produce about 32 tons of carbon emissions over its life. So less than half of what the gasoline-powered car, but with clean electricity, it's more like 15 or 16. This is closer to what it looks like for consumer power, by the way. I think I did the calculation. I think it was 17 tons over its lifetime versus 108. And manufacturing is getting cleaner all the time too, so these manufacturing numbers are going to go down. So that's why it's important to understand that they're cheaper to operate, their life cycle emissions are dramatically lower, and a lot of the mythology out there that is contrary to that is just not true. So here it's the ending point. These are the 4 biggest sources of carbon emissions in your life, and we should all be thinking about replacing these as soon as possible before they break, because when they break is the wrong time to be thinking about doing that. That's a crisis mode. It's best to avoid that. We have tons of information on our website about how you can do this. We have a newsletter you can sign up for, which has great tips and discounts that come up every once in a while that we can alert you to. And of course, we have webinars where we dive deep on every one of these topics that I've glossed over tonight in depth with manufacturers and installers, going into a lot of the details on the benefits of these things. So please check us out at electrifynow.net. And with that, I'm going to end my presentation. Thank you.
Thank you, Brian. That was really great, and I like your point. Let's not wait. Let's get going. And so what we have is we have 3 innovators from our local community that we want to introduce you to tonight. Actually, I found a lot of innovators around our community, and if you have an innovation story, we'd love to get it. But what we're going to do is have 3 people talk about what they have done to make us a better community in terms of mitigating and adapting to carbon change. So the first person is Wendy Woods, who's an ecologist from the who is retrofitting an older home. Now, many of the homes in Corvallis are 50, 60 years old. And so those are the ones that are very difficult to retrofit. So Wendy is retrofitting hers to be 100% electric. She has an electric car, and she wants to run the whole thing on solar. And the last I knew, she was only using about 4 kilowatts of solar. So that's a pretty efficient system. So she's going to tell us about some of her things that she's learned to accomplish this.
Am I on?
Yes.
Okay. Thank you very much, Court. Did you know that existing buildings emit nearly as many greenhouse gases as transportation? They're both around 40%. To reduce emissions, existing buildings will all need retrofits. As Eric will discuss, Passive House is a very high performance standard for buildings, which can almost eliminate the need for central heating. I'm retrofitting my own home in Corvallis based on guidance from Jan Fillinger, a Passive House architect from Eugene, and Carl Christensen, a Passive House certified builder here in Corvallis. Because my 1960s ranch-style Harmon home is like thousands of similar homes in town, what I've learned can be replicated in many of our older local homes. So tonight I'll give you a quick overview of effective methods, and later you can find more details on our website. It would be challenging to turn an older home like this into a certified passive home. However, Passive House principles, when applied to portions of the home can have a significant impact on energy use. Heat rises, so I began with the ceiling. I sealed off the opening of the chimney, covered the entire attic floor with spray foam, topped with deep fiberglass bats, and then noticed that my electric bill was reduced by half during the next winter. Why did I use spray foam? It both air seals the exterior surface and provides double the insulating value compared with other types of insulation. Combining air sealing and insulating is far more effective than simply insulating. So next slide. So my goals for doing this were to maximize the energy efficiency of the home within a reasonable budget, and to phase out fossil natural gas, to not use any fossil fuels, and to use all electric appliances, and to try to use solar panels to power everything in the house and the car. Next slide. An energy retrofit, the basics are you create a tight envelope around the outer surface of the house and super insulate that envelope and take anything that runs on fossil fuels and convert it to all electric appliances or equipment, and optionally add solar panels if your house is suitable for that. Next slide. To tighten the envelope, you can seal air leaks. So the way construction has been going for the last, I guess, 100 years or so, homes have a lot of air leaks and the heat goes right out through them. But you can seal that with spray foam and aero barrier. And aero barrier is a new product. It's basically vaporized latex, and it can seal all the nooks and crannies really quickly, whereas the old way of doing it was a caulking gun and tape. So you can create this way a continuous thermal barrier around your house. I'll show you that in a minute. And you can then super insulate that thermal barrier. Next slide. Here is a picture showing the thermal barrier around the outside of the house, the walls, the floor, underneath the floor, and the ceiling between the house and the attic. Those are the areas that are the thermal barrier. What I chose to do is just the ceiling and the floor, and set aside the walls because that's a little bit more complex and expensive. And next slide. So the windows, however, in the walls are a source of a lot of energy loss. And so it's worth putting in the highest quality windows you can. And this country Alpen windows are outstanding high quality windows. And I put in one of those, particularly in my living room where I've got a great big huge picture window, and it was leaking like crazy. So I replaced that with a high quality Alpen window that is triple pane and quite energy efficient. And all the other windows have Indo windows on the inside. That's an interior storm window. You can look up their website and they'll tell you all about it. It's a lot cheaper way to go to seal your windows off. And it also keeps the smoke out during the fires. It kept the smoke out of my house, keeps the pollen out during pollen season, keeps the noise out year round. I really like them. Next slide. So replacing the fossil fuel equipment with electric equipment, Brian's talked quite a bit about this, but I've lined them up in order of those that use the most energy on down to those that use maybe the least energy. And it's really important to do the furnace, the water heater, and the gas stove, because those use the most energy in your house, and they can be replaced with much success by heat pumps and heat pump water heaters and an electric or an induction stove. Next slide. So Brian's already talked about this, so I'll just show you the slide and let's go to the next slide. Here's a heat pump water heater. That's how they look from the outside. Next slide. And here's an electric fireplace. Since I sealed off the chimney, I put in an electric fireplace and I still have the same ambiance. It's quite lovely. Next slide. So the results of this retrofit are, this is an all electric house, and the car, I also have an electric car. It's an older Nissan Leaf, so it has a smaller battery. It uses less than half the electricity as before the retrofit, and that includes charging the car. I don't drive a whole lot, but I do drive most every day. No fossil fuels have been purchased for 2 years. I'm much more comfortable in my home, and it's also more soundproofed, and it operates mostly on the solar power on my roof. And if you want to learn more about all of this, you can go to electrifycorvallis.org. And I hope that you have learned a few things from this presentation.
Thanks, Wendy. That's really great. You've really shown us, some of us who have these older homes, that there is hope and a lot we can do. Now, going to the other end where you're building a new home, Eric Ream's an oceanographer, and he is building a new home and using passive house principles. Now, there's a difference between, well, he'll explain this, but passive house principles and a passive house are somewhat different. But anyway, Eric, why don't you help us out on that?
There we go. Hi, everyone.
Passive House explained in 90 seconds.
Sorry, we're going to talk a little bit about what the passive house principles are first, and then we will discuss how they play in both new and retrofit construction.
Passive House explained in 90 seconds. Does your house have a heater in the basement or maybe a fireplace? Probably also a central air conditioner or maybe a window unit. Did you ever wonder if it was necessary? In 1991, a physicist in Austria, Dr. Feist, built the first passive house. Here's what he did. 1. Proper insulation. It's just like wearing the right winter jacket, it also doesn't need a heater. 2. No air leakages. There should be no holes, small or large, to let hot air out of the house. 3. No thermal bridges. A thermal bridge is like a road for heating energy in which warmth can travel right through your walls. As a matter of fact, most of our houses have thermal highways in our walls where heat can easily travel to the outside. Plus, the house needs proper windows most of the time with triple pane glass. It needs to be oriented properly so the sun can heat it in the winter and shade is provided in the summer. And it uses an HRV, a device that provides the inside with fresh air without letting the heat out. Add all these things up, and it turns out your house doesn't need a heater or air conditioner. So where does the heat come from? A passive house needs 90% less energy, and that can easily be supplied by your body heat, the sun, your appliances, light bulbs, and even your TV. This saves you a lot of money on your heating bill and helps preserve the environment.
Did we make it in 90 seconds?
You bet we did.
Well, there we are. These are the passive house principles, and they work for all buildings, and they also work for both new construction and retrofit construction. So I'll just go over them briefly, and I'll point to what I'm doing in my new house. With proper insulation. So in my house, I have not only a set of insulation in the wall, and I'm using a sustainable material, dense packed cellulose is term, it's carbon negative, but also on the outside to prevent those thermal bridges. There is about a 2.5-inch thick set of continuous external insulation made out of wood fiber. Together, this makes over an R30 wall in the rating system of insulation, and this is beyond code. No air leakages. So when the house is being built, there is essentially an air barrier that's continuous through the entire inside of the house, just like in the passive house in 90 seconds. It's a bit like a balloon that is very tight. So since the air is so tight, since the house is so tight, the air concerns about air quality are such that there's active ventilation to bring in fresh air, and the heat from the exhausted air is captured or the coolness is captured. For thermal bridges, I talked about the continuous external insulation on the outside of my house. Also have triple pane windows throughout the house. For orientation, we want it oriented towards the sun. So the front of my house is conveniently oriented towards the south or southwest, but we want not too much sun. So in fact, I don't have too much glass on the south side so that the house doesn't heat up too much. I do, as I mentioned, I do have active ventilation. We'll have active ventilation to maintain the air quality that improves the health of the household. I'm also going to be completely electric, so there will be no combustion on the inside. I will not have a fireplace that uses wood or gas, and I won't use any gas appliances inside the house. So this all results in minimal heating and cooling requirements, which means that the heat pump they do have to purchase is actually smaller than the average home. Now, international and state building codes are evolving towards passive house standards, where the passive house standards are set very high with respect to that potential of a 90% reduction. But you don't have to meet the passive house standards to do a good job. Just as you can choose how thick a down coat you might purchase, for the winter, you can choose, based on your budget and on your heating systems, how much, for example, how much insulation that you will put in. There is an Oregon residential reach code, which is an optional set of codes that is not mandatory. And but these are something you can point your contractor or your builder to and have the discussion about how to meet these aspects of proper insulation, no air leakage, no thermal bridges, and so on. So passive house design is one of the most powerful tools available to dramatically improve energy efficiency in both retrofits or new homes. We're combining essentially a passive house principle to maximize the energy efficiency in the building. We're going to minimize the materials that have made of carbon-based materials upfront carbon emitted from construction. We're going to electrify anything, and we're going to power it all from clean energy so that we can have a zero carbon building. Thank you. We have some resources. We can make these resources available to you afterwards. Point is, there are people who will help you analyze your home here in Corvallis. There are new construction guides that your contractor and architect and or builder or retrofit contractor can refer to. And there is help in removing financial barriers, both from the Energy Trust of Oregon and from Seeds for Soul. And we're going to hear from Julie Williams about that next.
Thank you, Eric. That was great. And you can see that there's ways to, if you're thinking of building a house, how you can build in some of these passive house concepts. Also, we might note that there are free retrofit clinics that you can obtain by contacting the Sustainability Coalition or Electrify Corvallis. And these are individualized, so they'll help you with your own retrofit and change. Now, Julie Williams is the founded Seeds for the Soul. She's a high school teacher who taught sustainability for many years in Corvallis High School. And she's going to deal with this all costs money. And what Julie is trying to do is help all of us be able to get some of this going. And as Brian has indicated, we'd like to get going soon. So Julie has some good insights for us on how to fund some of these options.
Right on. Well, thank you, Court. Can you all hear me? All right. So that's some great information that we've heard so far. So how do we make it reality? Like, what is the bottom line? Seeds for the Soul was founded in 2012 after I had put solar on my home. And I learned that what I thought was going to be a very expensive and very complicated project turned out to be simple and relatively inexpensive. You may be listening with an ear to participate as a solar client or an energy efficiency client, but you also may be listening as a way to participate in just addressing our carbon mitigation as a donor or a sun buddy. So we'll explain what those things are. So go ahead and do the next slide. Seeds for the Soul utilizes a revolve loan method to fund energy efficiency projects and recycles the funds and repeats the process over and over. So Seeds for the Soul will provide gap funding. So once you see all of your incentives and you get your bid from your installer for whatever energy efficiency you want to utilize, whatever the gap is from the incentives to what you need, if you're low to middle income, we will loan you whatever you need to complete your project and then design a personalized payback schedule that hopefully is balanced with what your return on investment will be in energy savings, so that it will have a zero impact on your monthly budget. Once everything's paid off, then you have a very positive impact on your monthly budget. Now, how do we do this? Well, first you need to know that we help fund solar and ductless heat pumps, heat pump water heaters, and insulation, because those are the kind of the biggest movers in the right direction. We get our money through donations and wealth sharing. Well, wealth sharing is just people in our community that allow us to use their savings. So they give us a zero interest loan, and then we seek clients and give them a zero interest loan to do their project. They pay it back to us. We pay it back to our sun buddies that loan to us. So in this way, we kind of get a chance to invest in your neighbor, and it has a positive impact on climate, and it also addresses energy equity in our community. So we see it as a community builder. Next slide. So the biggest barrier to accessing these substantial incentives for energy efficiency is the upfront cost. And then after that, the second biggest barrier is generally lack of information and support. So remember when I said it seemed complex and expensive? Seeds for the Soul's primary service is to educate and communicate and provide outreach to underrepresented and low to middle income clients. And actually, we'll give information to anybody. We've traveled the path for these energy efficiencies numerous times. We know who some of the strongest installers with the highest integrity and the lowest prices are, and we're happy to share all that information with anyone. But primarily, we work with our gap funding for low to middle income people. So next slide. How it works, I kind of did tell you that already, but we contract with individuals or organizations. The UUFC, the United Unitarian Fellowship, has afforded us a SunBuddy loan for years, and they just let it revolve. The city of Corvallis has provided us with really low interest loans. And then the rest of our funding comes from individuals that we contract with. And so it's pretty cool how the wealth sharing starts. We pass those loans on to LMI clients. They install or complete their project, and then they pay us back based on their savings. So if they put 6 kilowatts of solar on their home and they expect to save $75 a month on their power, they'll pay us $75 a month until they've paid off their loan. Usually it takes 5 to 7 years. And then after that, they just pocket that cash for themselves, which is awesome. So that just keeps happening over and over. Next slide, please. So while zero interest loans are great, donations are even better. They provide us with flexibility. When we have people who cannot do their payback schedule in 4 to 5 years, we can extend it a little longer and keep their payment prices down when we have donations. But also, they continue to work in perpetuity. So for example, in 2014, Mr. Spartan, it's a fundraising pageant at Corvallis High School where I work, or used to work, they provided us with a $20,000 donation. And we have applied that $20,000 through our program over 4 times now, making that $20,000 do the work of $80,000, and it's still working. So we've figured out how to multiply money. It's kind of interesting for the good of the planet. Seeds for the Soul provides an ethical carbon offset program, and we can guarantee a true offset and can calculate it for you. There are marketplace offsets that you might find through an airlines or big offset companies, and we call them marketplace offsets because what they do is they can sell their offsets like by planting a forest and different means to polluting companies who buy them very cheaply and then keep on polluting. Well, we won't do that. So donations to Seeds for the Soul don't land on a single project, but return to us and are reapplied to the next project over and over and over. We've also created a playbook that you could replicate Seeds for the Soul in another city, in another place. And we're replicating right now with Silverton, the community of Silverton. So they're going to have Silverton Seeds for the Soul. Next slide. You may be wondering if you qualify as low to moderate income. And so see if you can find your financial situation on this chart with a household size of 6 or a household size of 1. The ODOE, that's the Oregon Department of Energy, they provide some really nice solar incentives and some other incentives if you meet that criteria as a minimum income. And then Energy Trust of Oregon's are just a little bit more generous. But right now, Pacific Power and PGE would provide $6,000 towards the installation of your solar. And then you can get even more from federal government and more from ODOE. They'll also pay 100% of the installation of insulation and ductless, 2-headed ductless heat pumps right now. So we really want you to contact us so that we can put you in touch with those programs. And then the last slide, please. So there's been a lot of excitement about the Inflation Reduction Act, and it provides huge tax credits and rebates for energy efficiencies, and some of these efficiencies to get us off of natural gas. The IRA holds some great promise in mitigating CO2 and could keep 1 gigaton of greenhouse gases from entering the atmosphere each year if we all would take advantage of them. So remember how the second biggest barrier to energy efficiency is lack of information. Well, if we click on the link there, and Eric, you might have to manipulate this. Yeah, so right here we just put a homeowner making 65,000 a year. Maybe we could fill that all in, I don't know. But you hit the calculate, yeah, make a homeowner. Household size, make it 3. And tax filing, single or joint, doesn't matter, pick one. Yeah. Thank you, Eric. And then hit your calculate button. This is on Rewiring America's website. It'll be the first thing that pops up. And as he scrolls down, it'll show you what your upfront discounts are, and then available tax credits to you if you were in that situation. And you'll save $1,400 a year on mitigated energy efficiency. So your total incentives are $18,300. And if you continue scrolling down on this app, it shows you what you can get. You can get $1,750 towards a heat pump water heater, which if you go through us, it'll pay for the whole thing. That heat pump air conditioner, the different kinds of stoves, induction stoves, and it continues. So these are the upfront discounts that just come off at the start. So if you're low income and you don't have enough money, you're not making enough income to gain on the federal tax credits, you can still get those. And then all these others are just amazing. A new electric vehicle gets $7,500. Basic weatherization, a new electric panel. If putting solar in makes you have to redo your electric panel, there's money for that. So anyway, explore that at Rewiring America. And then last slide, please contact us at Seeds for the Soul, especially if you're LMI. But if you just want a little hand holding and a little guidance through how to do some of these measures that Brian and Eric and Wendy outlined for you tonight, we are happy to provide advice and gap funding. So see us at Seeds for the Soul and we'll get back to you. And thanks so much for this opportunity.
Well, thanks, Julie. While you're typing your questions in the chat, I'm sure you have some questions, but what's not to like about all this? I mean,
Wow.
really, help the climate, make things cheaper for yourself, cleaner air, use less water,
Right?
maintenance. I mean, golly, don't run away now. Ask your questions.
Julie, that was fantastic.
Brian's going to handle the question answer.
Well, I just wanted to say I'd heard good things about Seeds for the Soul, but it was really fun to hear more about it. And man, we need to figure out how to replicate that in every city in Oregon. So we should talk about that.
Thank you.
I'm just looking through some of the Q&A, and if you have other questions out there, please put them in. I see there are a couple here that look like they were directed kind of my way, so I'll maybe start with some of those. But there's a question here about solar water heaters, and solar water heaters are great. I'm a fan, but I think what's happened in the marketplace is that electric heat pump water heaters have kind of taken the place of them as a more easily kind of off-the-shelf solution. But solar water heaters can be great. I don't know if Eric or Julie, or anyone here has more familiarity with those devices. I tend to just steer people to heat pumps because they're really easy off-the-shelf solution. But any thoughts on that, Julie or Eric?
I would just say my solar trade ally, as I'm working with Energy Trust of Oregon, just advised me that, for the cost, an heat pump water heater was so much cheaper than adding on the solar collectors, and that essentially by maximizing my space for photovoltaic or for electricity, essentially I was, and the cheaper price of the water heater than the liquid-based solar water heater, that I was ahead there.
Yeah, that's what I've been hearing as well.
I agree as well.
There's a question here about refrigerants and refrigerants. Well, this is a great topic. I mean, I would start by saying, yes, it's true. Heat pumps, refrigerators, air conditioners, your car, all these things have refrigerants in them, and refrigerants are a problem because they have, if they escape into the atmosphere, they have huge global warming potential, sometimes thousands of times more than carbon dioxide does. Having said that, for the most part, there aren't a lot of refrigerant leakage that happen day to day. I say that, I don't mean to be glib because I don't mean to sweep this problem under the rug, but a good heat pump installer is very well trained in how to avoid leaks, systems tend not to leak much. But even when they do, and I've seen calculations from people like NRDC that put in a factor for leakage into their calculations about the climate benefits of heat pumps still come out amazingly ahead of any other solution. So first of all, I would say don't let refrigerants scare you from getting heat pumps. Having said that, there is some really good work that's being done on refrigerant improvements, and we've come a long way from where they were, but there's still a long way to go. There are some systems that actually use CO2, which have very low global warming potential. There's very likely to be a new generation of refrigerants that's brought to bear because of this Kigali protocol that was just signed today, I believe, by President Biden, which is a refrigerant-focused agreement as part of the Montreal Protocol that started years and years ago. And we know that there's a lot of research being done with the HVAC community and the manufacturers about how to lower the global warming potential. R32, which is one of the things that's out there as a potential for a new standard, is about a third or a quarter of the greenhouse, the global warming potential of current refrigerants. So they're going to get better, but I would say don't let that scare you from doing the right thing. Make sure though, don't just chuck your refrigerator into your backyard though either, and risk, the refrigerant that's in your refrigerator from leaking in the atmosphere. Any thoughts on that from Eric or Julie or Wendy or Court?
I had the same concern in my new house with respect to where should I locate the mini split heads, and I thought we really have to minimize the amount of refrigerant, so let's minimize the length of lines. And I had read some information about what the assumptions of global warming models were with respect to the leakage of this over the next year. But I was actually reassured by people who do consulting on solar-based heating quite regularly, or essentially net zero homes, that the current heat pumps, both the kind that you showed with a centralized ducted system, as well as mini split heat pumps, the amount of leakage per year is very, very small. So you do want to have your heat pump maintained and serviced, regularly. That's true with any heating system, but the overall leakage is very small. That said, obviously moving to refrigerants with lower global warming potential is a good thing for the planet.
Yeah. Julie, here's a question for you. How many homes in Corvallis have benefited from the Seeds for the Soul programs? Do you have a number off the top of your head there?
Yeah, I think we're up to 205 in
Wow.
Corvallis, in the Corvallis area. Yeah, so that's solar, ductless heat pumps, heat pump water heaters. We're doing our first homes with insulation this month. So we went from just solar to trying to have kind of a menu of things that people could do, because different communities can utilize different things. Like a mobile home usually cannot put solar on. So we're like, how can we impact them? Can we get the heat pump water heater or ductless heat pumps into those spaces? So it's just trying to serve more people and more distinct income levels that's driving us.
That's fantastic. Eric, here's a question for you. How do you keep smoke from entering through the active ventilation? Can you elaborate on the filtration system that protects against contamination from outdoor air pollution?
Sure. The active ventilation systems do have air filters, and they use the highest quality air filters. Not all of them are the highest performance grade that you would find, let's say, for removing, bacteria and viruses, but most smoke particles, the ones that we're concerned about, are much larger than that. So when we're talking about, 1 and 2.5 micron particles, these are used as the particle indexes when you look up air quality on a website. Particularly, we're getting used to that with more regional smoke and fires. These kinds of particles will be removed by essentially what's called MERV 13 level filtering. Optionally, you can add the HEPA level filtering to these systems if your, respiratory concerns are of even higher, need higher filtering.
That's great.
Yeah, Brian, can I jump in?
Yes.
So I had during the fires, I had a lot of difficulty with my HRV sucking in the smoke. And what's been recommended is installing a carbon filter to get the smoke out. But I had a MERV 13 and that was not cutting it at all.
It's interesting.
That's a good point. The air filtration systems that I was talking about are for particles and not for smoke.
Yeah, we've found that these Court, looks like you got your hand raised there.
Well, go ahead. Say what you found.
Oh, it's just that, there's these very inexpensive air filtration systems, like Blue Air is one. There's several that are on the market. I'm a fan of the Blue Air ones just because I like the way they look. But, for $250 or $300, you can get a box that's, the size of a stereo, those old stereo speakers we used to have in our houses, and that will clean the air in a pretty big sized room or several rooms, even if you leave it running continuously. They're relatively quiet, they're relatively cheap, and I've used them during, a couple years ago when we had that air. I'm an air quality geek here with sensors all over the place, and we had air outside that was over 400 AirQI index, and inside it was 12. And partly it's because we were able to, our home system was good, but we were running these additional filters that are really good at cleaning the air. And like I said, they're not that expensive. So that's another thing you can think of as in your toolbox is it's good to have one of those, particularly when the power goes out, because a lot of times when the power goes out, which is a question that hasn't been asked that I didn't see here, but resilience is an important thing to be thinking about. Your gas furnace won't work, your gas stove shouldn't be used, so the idea of gas is resilient is not a good one. But you can buy these small batteries for like $1,000, and you can run one of these air filters for a long time onto that, and at least keep your internal air clean if you've got a wildfire and a power outage at the same time. So these little hacks can be really helpful. What were you going to say, Court? I cut you off.
I was just going to say my experience was during the 2020 fires when it was the air quality was between 400 and 500 in Corvallis. I have a cold weather heat pump that heats and cools, and it goes through a HEPA filter, and the fan runs all the time. And we had no smoke at all in our house, and the air quality thing is down on Circle, which is quite close to our house. So I don't know, maybe it was just dumb luck, but anyway.
No, they work. They definitely work. They definitely work. Yeah. Someone asked a question about community solar and how do you get information about that. I put a link in the chat. This is to our website, and unfortunately, I don't think the Oregon Community Solar Program website is very good, so I don't send people there. I send them to Oregon Shines is a good place to go. Neighborhood Energy is one, and Common Energy. These are three good ways to sign up for community solar. Community solar is like a screaming deal, but you have to be either in PGE territory or Pacific Power territory to be able to subscribe to community solar. So it won't work I don't think you'll be able to do that as a consumer power consumer unless there's a local one that's happening. Julie, I see you've got a comment there.
Dan Orzik of Oregon Clean Power Co-op is starting projects with community solar. His first one is happening down in Klamath Falls in Pacific Power region, but I believe he has two projects that will be coming online late in 2023, two in PGE and another one in Pacific Power region that will be open for investment. So he's doing a little different. A compilation of investors will work together, so anybody can sign up. And so I'd go to his website, Oregon Clean Power Co-op, and I'll put that in the chat, and you can get on in the queue to be an investor or to subscribe as a low-income household when you can get 40 to 50% off of market price for electricity and have a clean energy source without having to invest. So I'll put that in there
Yeah,
now.
that's great. The laws around community solar here in Oregon are fantastic. I mean, just as a non-income qualified subscriber, you'll save roughly 5% on your electricity bill. So you're getting 100% clean energy and it's cheaper. But as an income qualified subscriber, it can be up to 40%, which is pretty amazing. So it's a really good deal. And I'm really wanting to support this and make sure it's successful. I don't think there will be a problem, but it's surprising how few people know about this. And it's almost like this is almost too good to be true. And I know that there have been struggles to get enough low income subscribers. So it's good to get the word out. Okay, what else? Let's see, what are some of the other questions we have here? We've got quite a few. Some about the IRA, about the rules in Oregon. I mean, there will be specific Oregon-related nuances to the IRA as it's, but I don't think we'll know about that for a while. Probably be into next year. But the IRA calculator from Rewiring is a pretty good first start. It's going to get you pretty close to what's going to be available. Let's see. Is there anyone local who can provide geothermal heat pumps? Oh, sorry. Did Wendy or Julie, did you have a comment on that last thing?
No.
My
Okay.
comment's on a different question.
Oh, go for it, Wendy. Go for it. Jump in.
So Keith is asking, can we get ourselves into a situation where we electrify everything and have to deal with major power outages? I've known people in Oregon who I can't see the question anymore. So anyway, I think that, I mean, I apparently got in before the law changed, and I've got an inverter that I can flip a switch when the power's out, and I can charge whatever I want off of one power outlet. So I could do emergency charging from that. But apparently right after I got that installed, it has been disallowed. So that would be one solution. I don't know if there's any way of getting that law changed, but I think that would be a good resilience measure if we all had that.
Yeah, my understanding is that now our system is the same way, but understanding now that you have to have a battery in order for that to work now. But I guess the thing, first of all, I would say, like I said before, don't be under the impression that gas in your home makes you more resilient, because it just really doesn't. I mean, there are very few gas devices that will work when the power goes out, because most of the gas devices have an electric fan or electric ignition or something that makes them not work. Or like I said, a gas stove for cooking. I guess if you open all your windows, maybe, but you're poisoning yourself to use that if you don't have ventilation. So for the most part, it's important to know that gas is not a good alternative for resilience. But I acknowledge the resilience issue. Solar power and storage is an awesome solution, but it's expensive. I mean, personally, it feels to me like I have a little bit of trouble wholeheartedly advising it to people. I mean, I think if you can afford it, it's great. I think the solution that I'm more excited about, it's going to take a while to come along, is the ability of our electric vehicles to provide backup power. Because if you think about it, I have an EV sitting in my parking lot that's got like 3 times more battery capacity than what I would be able to get if I put in a Tesla Powerwall or something like that. And that Powerwall system in it, I don't mean to pick on Powerwall, they're all expensive, could cost like 20 or 30 grand, and it would be sitting around doing nothing most of the time. So I think the vehicle to grid thing is really exciting, because as soon as you're able to get energy from your car that's sitting out there, and when there's a power outage, usually you're not going anywhere because there's nowhere to go. So you could be using your car to drive power most of the things in your home. So I'm excited about that. But in some of the cars, like the Ford F-150 Lightning has that capability. That capability has to be built in the cars, but also has to be built in our homes. So it's going to take a little while, I think, until that becomes a reality. But that's the biggest hopeful thing I see on the horizon in terms of dealing with a lot of problems all at once. The resilience issue, but also battery, electric grid stability, and time of use advantages, all sorts of things that come when as soon as we get our cars so that they're not just sucking from the grid, but they can actually give back to the grid as well. Okay, yeah, there were a couple questions on ground source heat pumps versus air source, or geothermal versus air source. Geothermal heat pumps are amazing. They tend to be expensive. So typically for individual homes, they don't often make sense from just a cost standpoint. And now that air source heat pumps are so efficient, the difference in efficiency isn't as dramatic as it used to be. But there can be a real role for ground source heat pumps. In fact, I was having this, some of you may have been hearing about some of the things that are happening with more like district heating and cooling, where you might be able to run a whole neighborhood off of a large geothermal heat pump. That sort of thing makes sense, particularly I think longer term, as we imagine this problem we have of literally dismantling a very complicated gas heating system in many neighborhoods that we live in, particularly in cities. So the idea of like basically shutting down a whole neighborhood at once and replacing the gas heating to those homes with a geothermal heat pump system might be a really cost-effective way of dismantling the energy system in a more systematic way. But when we're talking about individual homeowners and doing it on a voluntary basis, it's a little bit hard to recommend geothermal just because of the cost. There may be some situations where it makes sense, but I don't know. You guys jump in if you have contrary information, but that's the way I see it. Court, have you had some experience with that? All right. What other? We're kind of running short on time here, but do we have time for one more? Or do we have an adequate cohort of contractors in Corvallis who are competent to install heat pumps, solar, etc.? I think Julie's going to be an excellent resource for that.
Yes.
And Wendy, I know we've had conversations about this. I've figured out how to find the good ones in the neighborhoods where I've focused, but I haven't really worked on Corvallis. I'd be happy to help. But the short answer is we could use more. We will need more. We will need more good qualified contractors, but they do exist, and I'm sure a lot of people on the call here could help you if you have specific questions.
Good answer.
I think we're getting close to time here. Do we? What do you think, Court? Should we wrap it up, or any thoughts
I think
about
it's
final
fine
questions?
to wrap up. I'd just like to thank everybody for spending some time with us this evening, and I hope you feel it was beneficial and ask questions. You can certainly contact any of us. There are lots of other sources where you can get information. I guess the issue is let's get going. You could really probably save yourself some money this winter by starting to do some of your retrofit activities. So anyway, all the best. And anyone have any final comments? Wendy, Eric, Brian, Julie?
No, just thanks everyone for tuning in, and good luck with your electrification projects, and reach out to any of us if you have questions. We're all willing to help.
Thank you, everyone.
Thank you.
Thank you.
Bye.
Good night.